Hello everyone. Today we will continue with the chapter 2, electric potential and capacitance. In the last class we talked about electric potential, potential difference and electric potential due to a point charge. Today we will talk about electric dipole and its potential. Potential at two different positions, its special cases, equatorial position, axial position, but we won't derive those two. We will only derive it for arbitrary case, and its special cases will cover both the position. Then characteristics of electric potential. Then superposition principle, relationship between electric field and potential difference. That's a curtain raiser. That will help you understand why did we use the unit of electric field as volt per meter also in the first chapter. So there is an important relationship. E is equal to minus dV by dr. Okay, let's start with the first theory then. Electric potential at any arbitrary point due to an electric dipole. So here AB is an electric dipole. Here is negative charge, here is a positive charge. P is the point which is at distance r from the center of the dipole where we want to find our potential. R1 and R2 with the distances from A and B, that is minus Q and plus Q respectively. Let's say that P is making an angle theta with the dipole axis, that is the axis passing through minus Q and plus Q, or with the dipole moment P. The distance between them is 2a. If I draw a perpendicular from this, that's a small construction you need to remember here, then this part, this remaining part will become R1 minus R2, and that will be really important in deriving this electric potential due to this charge, due to this dipole. If this is angle theta at point O, then point P will make angle theta as with minus Q as well. Why? Because dipole is a small system. So even with B or with O, with A, there won't be much change in the angle made by point P. So almost they are the same angle. Okay, so AP is R1, BP is R2, and you will need this diagram here. If you go through this right angle triangle, if you, let's say here you give the name A and B. So in a right angle triangle A and B, if you take cos theta, that is adjacent side by hypotenuse, this is your adjacent side R1 minus R2, and that is hypotenuse. So R1 minus R2 will become 2a cos theta. Why do we need it? We need it for the derivation of the electric potential due to the dipole. Let's go for it then. What will be the potential? Just add the two potential due to minus Q and potential due to plus Q. So the net potential at P here, call it V1 and V2. V1 is the potential due to minus Q with a negative sign, and this is the potential due to plus Q with a positive sign. So now take K common, Q common. So in the bracket it is 1 upon R2. मैंने इसको पहले लिखा है with negative sign, उसको आपने बाद में लिख दिया है. And if you solve the bracket, it is R1 minus R2. In the denominator it is R1 and R2. So I told you, where do we need that R1 minus R2 cos theta? देखो ये जो R1 minus R2 था उसको हमें हटाना है, तो उसके बदले ये 2a cos theta आ जाएगा. Now point P, dipole is a very tiny system. So if point P, it lies very far away from the dipole, then these two distances R1 and R2 are almost same, and if you multiply, because you have this multiplication here as well, so if you multiply these two, it will be R1 into R2, which is almost equal to R, that is the distance from the center of the dipole O. So R1, R2 और R तीनों almost equal है. सो यहाँ पे कैंसिल करने मत चले जाना, यहाँ पे आप बोलोगे सर R1 माइनस R2 है, तो इसको कैंसिल कर देंगे तो दुकान यहीं पे बंद हो जाएगी, ये सब खत्म हो जाएगा। Everything will become zero. The potential at point P, any arbitrary point, arbitrary का मतलब कोई भी point है, कोई भी point जो आप 360 डिग्री पे कंसिडर कर सकते हो। सो अगर ये R1 माइनस R2 में RR रख दोगे तो वो जीरो हो जाएगा, तो वो नहीं करना है आपको। So from that triangle, if you take cos theta, which is R1 minus R2 by 2a, so R1 minus R2 आपको 2a मिल जाएगा। Substitute this value here. So यहाँ पे आप substitute करोगे तो KQ into 2a cos theta नीचे हो जाएगा R square, and you will have this equation KQ cos theta by R square. So what's the magic you have done here? Well, you are a magician and you have brought this 2AQ in the denominator. What is 2AQ? It's a dipole moment. I have been telling you from the very first class कि डाइपोल के लिए जब भी आप काम करोगे तो आपको हमेशा न्यूमरेटर में या कहीं भी 2AQ लाने की कोशिश करनी है। आपने ला दिया तो इसके बदले आपने रख दिया है यहाँ पे P. So K into P into cos theta by R square. Now cos theta pops up when you talk of scalar product. So अगर cos theta हटाते हैं हम तो हमें डॉट रखना पड़ता है, तो ये cos theta हटा दिया आपने तो ये डॉट रख दिया, and cos theta जब भी आप डॉट रखोगे so it is a product of two vector, तो P को आपने वेक्टर फॉर्म में लिख दिया। अगर मैं नीचे R स्क्वायर ही रखता हूँ then I will have to put here R cap. R cap is a unit vector. You know the beauty of unit vector. वो किसी भी क्वांटिटी को वेक्टर बना देता है without changing its magnitude. So यहाँ पे भी आपने ये जो R cap रखा हुआ है, अगर आप ये डॉट यहाँ से हटा देते हो P डॉट R cap के बीच में, सो ये P1 cos थीटा हो जाएगा, तो आप फिर से आपको ऊपर वाला इक्वेशन ही मिल जाएगा, ठीक है। यू विल एंड अप विद द सेम इक्वेशन। तो अगर आप R कैप लिखते हो तो नीचे R स्क्वायर लिखना है, पर मुझे अगर वेक्टर फॉर्म में लिखना है सो आई कैन पुट P डॉट R एज वेल। सो अगर मैं R वेक्टर के फॉर्म में लिखता हूँ तो नीचे R क्यूब लिखना पड़ेगा। अब आप डॉट हटाओगे तो पी आर कॉस थीटा हो जाएगा, एक आर नीचे वाले क्यूब के साथ एक पावर के साथ कैंसिल हो जाएगा, फिर से आपको यही वाला इक्वेशन मिल जाएगा। सो इफ इट्स वेक्टर इट्स क्यूब इन द डिनोमिनेटर, इफ इट इज यूनिट वेक्टर इट इज आर स्क्वायर इन द डिनोमिनेटर। सो दैट्स इट, दैट इज द पोटेंशियल एट एनी आर्बिट्री पोजीशन। आर्बिट्री मतलब किसी भी पोजीशन पे आपका ये पोटेंशियल का इक्वेशन है के पी कॉस थीटा बाई आर स्क्वायर। सो इसे इक्वेशन में अगर आपको इक्वेटोरियल पोजीशन ढूंढना है, इक्वेटोरियल मतलब 90, तो आप यहाँ पे थीटा के बदले 90 रख दीजिए। सो इफ यू पुट cos 90 इज 0, तो पोटेंशियल 0 हो जाता है, तो पोटेंशियल एट इक्वेटोरियल पोजीशन विल बिकम 0। एंड इफ यू गो फॉर एक्सियल पोजीशन, सो इसी इक्वेशन में पुट थीटा इज इक्वल टू 0, so cos 0 is 1 and potential will be kp by r square, ठीक है। So that is for point P. So when point P lies on the axial position, theta 0 180 आप दोनों लेना पड़ेगा, potential maximum है and the value will be kp by r square, ठीक है। And when P is at equatorial position, the value of theta is 90 degree, and in that case the potential is 0. Is that clear? Remember, we have seen it earlier that the electric field at equatorial position is not 0, so the potential is 0, because in potential it is a scalar quantity और दोनों same distance होने की वजह से जब आप इसको ऐड करोगे दोनों potential due to plus charge as well as minus charge, they cancel each other and their potential at equatorial position turns out to be 0. Here are some characteristics of the electric potential. It is a scalar quantity. It is inversely proportional to square of the distance, whereas the electric potential due to dipole was inversely proportional to cube of the distance. We have seen that. Potential due to positive charge is positive because work has to be done by an external agent to carry the test charge from infinity to given point. And when you are bringing a positive charge in the proximity of another positive charge, remember the potential energy increases, and increase in potential energy is not a good sign. That is the symbol of unstable equilibrium. You are creating a chaos there. You are not helping the system to stabilize. Lastly, that is similarly, for negative charge, the potential is negative. That is, the test charge is attracted by the negative charge. Negative charge कौन है यहाँ पे आपका source charge है. So when you bring a positively charged source charge Q0 from infinity to the proximity of negative charge, so ultimately there is an attraction and the potential energy of the system decreases and the system goes towards the stability. Is that clear? So that is the difference between the potential of a positive charge and a negative charge. One increases the potential, creates the chaos, another brings down the stability. If you have two or more charges and you want to find out the potential due to each one of them on a given charge, for example here we want to find the potential on point P due to Q1, Q2, Q3 and Qn, then find out the potential due to each one of them and add them, and you will end up with this summation where you can add the potential due to each charges. So that is the superposition principle. Okay. Now this is a discrete distribution. In discrete charge distribution, you find out the potential due to each one of them, then go for the summation. If you go for continuous distribution, which we have done it earlier in the first chapter, this summation will become integration. Instead of Qj, there will be lambda dl for the line charge, that is one dimension, sigma ds or dA for the surface charge, two-dimensional case, and it can be integral of rho dV for the volume charge, three-dimensional case. So that you can do it with the help of the first chapter notes. You can go through that. Now electric potential due to spherical cell on the surface of the cell. Let's say कि आपके पास ये एक sphere है, sphere जिसकी radius r है, तो उसका potential इस sphere पे जिसके ऊपर charge q भी है is equal to kq by r. k के बदले आप 1/4 pi epsilon 0 रख सकते हैं. Potential का equation आपने देख लिया है, kq by r. So due to the spherical body, it is kq by r. Now potential on the surface is constant. If you go inside, then also the value of the potential is constant. Whatever is the value at the surface, if you go inside the potential inside the sphere, then also it is same. So V, that is the potential inside the cell, is also equal to kq by r, that is 1/4 pi epsilon 0 q by r. So it has the same value, the value it has on the surface. And if you go outside, that means now you are going away from this boundary. So at this point, the potential is maximum till this point. So what does this horizontal line mean? This horizontal line means कि ये कोई भी एक arbitrary कोई भी potential की ये value है y axis पे, तो वो आप center से लेके surface तक जाओगे, surface of the sphere, then the value of the potential is constant तो सरफेस से लेके सेंटर तक ये वैल्यू कांस्टेंट है और वो वैल्यू क्या है? इट इज k⁴/r. Now as you move away from the surface or of the sphere, then it varies hyperbolically, that we have seen in earlier chapter as well, because the potential is inversely proportional to the distance. Now it is small r, earlier it was capital R. You have to differentiate between these two R. Capital R, that means you are at the surface, or you might be between the center of the sphere and the surface. And small r, that means you are moving away from the sphere. Got it? Now we will derive a very important relationship. It's a curtain raiser, जिससे आपको पता चलेगा कि हमने इलेक्ट्रिक फील्ड का यूनिट फर्स्ट चैप्टर में वोल्ट पर मीटर क्यों लिया था. Okay, it's a 2-mark question, and there is a relationship between the electric field and potential gradient. Relationship is given by E is equal to minus dV by dr. So this term minus dV by dr is known as the potential gradient. Do you remember any more gradients? Temperature gradient, we have learned it in 11th standard, thermal properties of matter. We have learned in 10th chapter, fluid dynamics, velocity gradient. So whenever a given quantity changes with the dimension of length, we use the word gradient. So here potential V is varying with distance r, and that is why the term potential gradient. How to derive this equation? Let's go for it. See, here is our source charge Q. In its electric field, we have a charge Q0 initially at point A, then finally it will be at point B. And we are doing the work by moving it through a small displacement dr in the opposite direction of the electric field or electric force due to this charge Q. The potential at A, let's say it's V, and when you are moving this charge from A to B, you are raising the potential. The potential is increased. Why has it increased? Because you have now moved closer to the source charge by distance dr. So what is the increase in potential? dV is the increase in potential. It was V, now dV is the increase. So what is the potential at B? It is V plus dV. That is the value of potential at point B. So we have to apply force on this charge Q0 in moving it from A to B in the opposite direction of the electric field. So what is our force here? Force is equal to Q0 into E, that is with the negative sign. Why is this force negative? Because it is in opposite direction of the electric force. So that is the external force we need to apply on this charge Q0 in moving it from point A to point B. Remember, it is F is equal to minus Q0E. So what will be the work done? Work done, force आपका Q0E था, work done is equal to F dot dr. So that work done, force की value Q0E dot dr आप यहाँ पे लिख सकते हो. Now, because of your work done, that is the work done we have done in moving the charge from A to B, we have created a potential difference between A and B. So from the definition of potential, V is equal to W by Q. We make W the subject, so it's Q0 into V. That is the potential difference. So potential difference is equal to VB minus VA. If you substitute the values, you will have just dV in here. So W is equal to Q0 into dV. So that is another equation of the work done. One is the work done here, that is minus Q0E dot dr, and another is here, W is equal to Q0 into dV, that is in terms of the potential difference. Here, in terms of the force and displacement. So if you equate this equation 1 and equation 2, you will have this equation E is equal to minus dV by dr, and that is your potential gradient. So that is the relationship between the electric field and potential. In NCERT specifically, they have used this term, this phrase, this statement, that the electric field E here, electric field E is in the direction in which a decrease in potential. Why we are saying decrease in potential? Because of the negative sign is steepest. Steepest मतलब काफी ज्यादा है. So electric field एक चार्ज में से कौन सी डायरेक्शन में होगा? उस डायरेक्शन में होगा जहां पे उसका पोटेंशियल डिक्रीज हो रहा होगा. इलेक्ट्रिक फील्ड इज इन डायरेक्शन ऑफ द स्टीपेस्ट पोटेंशियल डिक्रीज. ठीक है, तो Q से जो हमारा सोर्स चार्ज है उसका आप इलेक्ट्रिक फील्ड भी देखोगे तो B से A की डायरेक्शन में है. तो B पे ज्यादा पोटेंशियल है, A पे कम पोटेंशियल है, तो B से A की डायरेक्शन में मतलब पोटेंशियल घट रहा है, उसी डायरेक्शन में इलेक्ट्रिक फील्ड है. ठीक है, सो E इज इक्वल टू माइनस dV बाई dr का आपको ये फिजिकल सिग्निफिकेंस लिखना आना चाहिए. Is that clear? So the electric field is in the direction where the decrease in potential is steepest. And you can see from the figure that it is from B to A, which I already have mentioned, that is in the direction of the decrease. With the help of potential gradient, we will derive an important equation which might be helpful in solving the numerical. We know that E is equal to minus dV by dr. So if you take this dr on this side and integrate this equation on both these sides, let's put the limit. This integration is over potential and here the integration is over distance, so your limits should be in potential and in distance respectively. So if we consider our initial position R1 at infinity, then the potential at this point is 0. Then from infinity, we bring the charge in the opposite direction of the electric field E by moving certain distance. कितना distance move करेंगे ये R के ऊपर आपको इंटीग्रेशन से पता चल जाता है. So infinity से आप R पे लेके आ रहे हो, तो जब R पे लेके आओगे तो वहां पे जो पोटेंशियल होगा that is V. So the potential at a given point P, जहां पे आप टेस्ट चार्ज को इंफिनिटी से लेके आए हो, जो डिस्टेंस R पे है फ्रॉम द सोर्स चार्ज, तो उसको हम डिनोट करेंगे V is a function of R. That means the potential at a given point R here is equal to the integral of the electric field into distance dr, okay, moving it from infinity to given point P, which is a distance r, in the opposite direction of the electric field. So this equation is useful in solving the numericals. Okay? Keep studying, keep revising, keep watching. Thank you. Thank you very much.